Hello everybody, welcome to another lesson in finding unknown angles in triangles. And we're going to be specifically looking at isosceles and equilateral triangles and the angles formed inside and outside exterior angles today. So you will need a couple of things. On RenWeb I have uploaded, it's really just a copy of the page in your textbook with the problems that we're going to be working through today. I'm sorry I didn't get a chance to stick that in your student packet, so you will need to print this out if you can. If you can't, that's okay. Just open up in your textbook to page 64, and it's the same thing. The only benefit of having the hard copy is that you can actually write on it, which I find very helpful. I'm going to get a pencil and just kind of demonstrate, as soon as we find an angle, you can fill it in. It's just kind of easier to track your work that way, and that's how I do it here on the board. So we have learned about the properties of isosceles triangles. Remember, they're triangles with two equal sides, and those two angles opposite one another between those sides are equal. And then we learned about an equilateral triangle, which has all three sides equal and therefore all three angles equal. And of course, all three angles are going to measure exactly the same in an equilateral triangle. They will always be 60 degrees. So using these properties and some of the other line and angle properties that we've learned, we're going to continue looking at some unknown angles. So the very first question on page 64 on your textbook, I tried to draw it as best I could here, is a diagram or a picture of a triangle with an exterior angle. And you're given some information. You're given that the triangle's name is PQR, and the lines QR is equal to PR. Those lines are equal. They're in the same length. You are also given that angle PQR is 65 degrees and told that QRS is a straight line. And you are asked to find angle PRS, which is this exterior angle here. So let's go back and think about, we're going to look at the triangle, and we're going to think about all of our triangle properties and line properties that we know to help us find out what we don't know. So let me tilt the camera a little bit here. All right, let's take a look at what we see. We see two equal sides. We know those little cross lines. Remember, we learned that those indicate that these two sides are equal. And if those two sides are equal in a triangle, we know that that means it's an isosceles triangle. And if it's an isosceles triangle, we know that these two angles are equal to one another. That's just one of the properties we learned. So we can go ahead and mark this angle as 65 degrees also. So we now have two of the three angles in the triangle. But we're not asked to find the third angle in the triangle. Instead, we're asked to find the exterior angle. And let's think back to what we remembered about the property of an exterior angle in a triangle. If one of the sides of a triangle is extended, see how this is extended from the end of the triangle in a straight line, if it's a straight line, then that exterior angle is going to be equal to the sum of the two opposite interior angles, right? So it's pretty simple to find this exterior angle. Angle PRS is simply equal to the two opposite interior angles, 65 degrees plus 65 degrees, which of course is 130 degrees. It's that simple. So the exterior angle is equal to the total of the two opposite interior angles. All right, that was number 6. Let's move on to number 7 over here. And in this figure, we're told that AB, this line AB, is equal to AC. That's important information. We are also told that angle DCE, this angle right here, is 75 degrees. BCD and ACE are straight lines. So this line and this line they're straight lines. And we are asked to find this angle, angle ABC. Well, let me turn my camera a little bit here. Sorry about that. Okay, so again, let's think about what we know to help us solve for what we don't know. Okay, so we know that these two lines are equal. We have a triangle here with two sides equal length. We know that means it's an isosceles triangle. Again, we know that the property of an isosceles triangle tells us that the two angles opposite one another on those equal sides are equal. So this angle is going to be equal to this angle. Well, if we get this angle, then of course that's going to be the same thing as that angle. And if you'll notice, we were told that this is a straight line and this is a straight line. So when we have two straight lines that intersect, we know that the vertically opposite angles are equal. That's one of our line properties. So that means that this angle is equal to this angle. And then we know that the two angles opposite one another in an isosceles triangle between those equal sides are also equal. So this is also 75 degrees. So we didn't even have to calculate anything for that one. Angle ABC is equal to 75 degrees. And I know that because of my triangle and angle properties. Okay, those are the first two. Now I'm going to erase my board, pause the video, and we're going to work through all of the unknown angles in number 8. So I'll probably have to do it in steps on my board here, but you're going to keep writing on this sheet of paper, and we'll move on to number 8. Okay, so I have drawn the first two triangles from number 8 on page 64. And remember, you can write on the page as we solve these. I recognize that there's a glare. It's a cloudy day. I'm sorry. I hope you can see okay. Let's start with the first triangle. We're given some overall directions for all 5 of these triangles. We're told, and I've written it here and it's on your paper, BCD is a straight line. So in every one of these figures, BCD is a straight line. And we're asked just to find the unknown marked angle. So let's take a look at the first problem here. So we're given a triangle and we're asked to find this exterior angle. So again, let's take a look at what we know and what we're given and see how we can use that to find what we don't know. Okay, so we know by the little cross lines that this is an isosceles triangle. And we know that the angles between the two equal sides are equal. And we are, in fact, given one of those angles. So if this angle is 50 along this side, then this angle is going to be 50 degrees as well, due to that property of isosceles triangles. Now we're asked to find the exterior angle A, and we know that this is in fact a true exterior angle because this is a straight line. So it's pretty simple to find angle A. Since it is the other part of an angle on a straight line, I'm just going to subtract 50 degrees from 180 degrees, and that's going to give me, 130 degrees. That's my answer for the first one, 130 degrees. And again, I asked myself, is that a reasonable answer? Yes, that's very clearly an obtuse angle, so 130 degrees is a reasonable answer. Okay, let's look at the second isosceles triangle here. In this figure, again, this is a straight line. We are told that these two lines are equal. They make up a triangle, so if the two sides are equal, then we know the two angles between those, opposite those, are equal. So we're asked to find angle B, and then we're only given the external angle of 110 degrees. So how can we use that to eventually find out what angle B is? Well, again, I know that all of the angles along a straight line add up to be 180 degrees. So here's my straight line. I can get this angle by subtracting 110 from 180 degrees. So let's try that. So we haven't even named the angle. We'll just say 180 minus 110 is equal to 70 degrees. So now we know that internal angle, and you can go, you can write it on your paper, write it in the corner there. We found that because we're going to use that to help us eventually find this one. Okay, so how do we find this angle? We have 1, 2, 3 angles in a triangle. Right now we only know one of the angles. So how can we find the other one? How can we find B when we only know one of 3 angles? Well, again, think about what you know about isosceles triangles. Again, those 2 angles between the equal lines, the equal sides, are equal. So this angle is in fact equal to this angle, because do you see that they're both in between and opposite the equal sides? So I already know the second angle of the triangle, and now I'm asked to find angle B. I have 2 of the 3 angles, and I know that they all equal 180 degrees, so now I can find angle B. Angle B is equal to 180 degrees minus, you can say 70 plus 70, or you can say 70 times 2, whatever works for you, same difference. Okay, so I end up with 180 degrees minus 140 degrees, which is 40 degrees. Now, is that a reasonable answer? Yes, it is. Okay. I also want to point out, I need for you to show your work. I need for you to write top to bottom, left to right. I saw on a lot of work recently where people were just kind of doing algorithms, like this, kind of off to the side. And I can't really follow your work. We've talked about that a lot throughout the school year. Please make sure you write out your steps top to bottom, left to right, because as the math gets more complex and complicated, keeping track of your work is really important. So make sure you're doing this as I do it. All right, I'm going to pause the video one more time and get the last 3 triangles up. Maybe while I'm paused, you can see if you can solve for those unknown angles yourself, and then work with me and check your work when you're done. Okay, I have drawn the remaining 3 triangles on the board here as best I can. I should say these are not drawn to scale. They are not perfect, of course. They're just me free drawing with a ruler. But they're supposed to look just like the triangles at the bottom of page 164. So let's go through how we can find the unknown angles here in each of these triangles. Hopefully, when you looked at all 3 of these, you noticed that they were all equilateral triangles because of the 3 crosshairs on each side of the triangle. So that's helpful. That sort of indirectly gives us some angle measurements, because we know that the property of an equilateral triangle tells us that all 3 angles within the 3 sides are equal. And all 3 angles add up to 180 degrees of any triangle. So when you divide 180 degrees by 3 evenly, of course you get 60 degrees. So let's stop right now, get your pencil, and we're going to fill in those angles. We'll start with this one. So automatically we can just go ahead and label each of the angles of this triangle as 60 degrees. We know we can do that because of these 3 crosshairs. That's what that tells us, that it's an equilateral triangle. Once you do that, you should note that you've been asked to find this exterior angle, and it's pretty simple because it's along a straight line, right? So, because we were told that BCD was a straight line. So that angle is next to a 60-degree angle, and together they add up to 180. So there's really 2 ways that you could solve for angle C. Angle C could be 180 degrees minus 60 degrees, which is 120 degrees. Hopefully you see that, and that's reasonable. Or you could have used the property regarding the external angle of a triangle. And that property says that the external angle of a triangle is equal to the sum of the 2 opposite internal angles. You could have solved it that way. So you could have said angle C is equal to 60 degrees plus 60 degrees, which of course is 120 degrees. So I see 2 ways that you can solve that problem. All right, moving on to the second triangle. Again, it's an equilateral triangle. I'm going to go ahead, take my pencil, and I'm going to label all of those triangle angles to use those numbers and measurements to help me find what I don't know. So here we go, 60 degrees, 60 degrees, 60 degrees. And hopefully you can see how much easier it is to actually write, physically on the paper rather than your own sheet of paper, because you can write in the angles. Okay, so we're now being asked to find, let's just look at it here. We have a straight line, and this entire angle right there would be the exterior angle. But notice that exterior angle has been broken up into two smaller angles. And so we're asked to find one of those smaller angles. Now, we're not given necessarily the measurement of this angle, but we are indirectly, right? Because we know that little square tells us that this little angle right there is a right angle, which means it's 90 degrees. So let's do that. Let's label that as 90 degrees. I'm just going to kind of erase that. 90 degrees. Now, once you fill that in, it should be pretty clear to you that this angle is one of three angles along a straight line. So this angle plus angle D would all add up to be 180 degrees. So if I have two of my three parts and then my whole of 180 degrees, I can easily find the value of that unknown. So angle D is going to be equal to 180 degrees minus the sum of the other two angles, which would be 90, doesn't matter what order, degrees plus 60 degrees. I'm going to go ahead and continue order of operations. That's 180 degrees minus 150 degrees, which gives me 30 degrees for this unknown angle. And I'm going to double check, is that a reasonable answer? Yes, it is. That's clearly an acute angle. That's a reasonable answer. All right. One more thing I want to point out. Let me write in that this is 30 degrees. This is just interesting to note. This entire angle right there is the official exterior angle of this triangle. So together, 90 and 30, if you add those, you get 120. And we can double check that that's correct by going back to our property that tells us that the exterior angle of a triangle is equal to the sum of the two opposite interior angles. So 60 plus 60 is 120, and that equals this whole angle 120. But I'll just point that out. You didn't need that to solve the problem, but it's just interesting to note. Okay, last figure is pretty interesting. Okay, so let's take a look. Let me just move this a little bit here at what we see. Again, we have this equilateral triangle, so we're going to immediately label all of our angles. We know that they are equal. Okay? Now, notice what we have here. We have an equilateral triangle, and then off to the side, they're sharing a side, we have another triangle that's formed. And we are given one of those angles, and then we have this angle, and then the third angle is marked as angle E. And we are actually being asked to find angle E, this angle. So, how can we use what we know to find that out? Well, again, you've got 1, 2, 3 angles. I know one of the three. I can't find the angle E without knowing what this angle is. Hopefully you see that. Well, I can easily find out what that angle is. We'll call that angle ACD because it's along a straight line. And this angle is next to it. So this angle plus ACD, this angle, is going to be 180 degrees. So let me find angle ACD. Angle ACD is equal to 180 degrees minus 60 degrees, which is 120 degrees. So let me label that. I'm going to go ahead and put that in there, 120 degrees. Now, looking at the third angle of this smaller triangle, I can solve for that because I know the other two angles. So to find angle E, I simply take 180, the sum total of all the angles in a triangle, and I subtract the sum of the other two angles. So let's try that. 180 degrees minus the sum of those two angles. 120 plus 40. Okay, so I'm going to do my order of operations. Again, making sure I'm writing my work out top to bottom, left to right in an orderly manner. Okay, 180 degrees minus 160 degrees. And that's going to give me 20 degrees for angle E. Is that reasonable? Yes, that's a really small acute angle. That's a reasonable answer. So I have solved for angle E, 20 degrees. So this is, what we're going to be working on here for the next couple of days. It's just using these properties, line properties, triangle properties, specifically focusing on isosceles triangles and equilateral triangles to find some unknown angles. And I hope you think I think it's kind of fun. I think it's kind of like a mystery you're trying, like a puzzle that you're trying to solve. So you'll have some homework to do over the course of the next couple of days. You're going to be working in your workbook when you do get to the assignment, and you're just going to be showing your work just like I've done here with some very similar problems. All right, so those are finding unknown angles, some examples of finding unknown angles in isosceles and equilateral triangles. Happy working, and we'll meet again.